Okay, so we did do this one. All right, guys, before we get started, are there any questions on the homework? Question over the homework assignments. We had a homework assignment over 1-1 and 1-2. We haven't had one over 1-3 yet, but we have had other assignments so far. So we're finishing up 1.3 today. What we looked at yesterday was, first we looked at horizontal and vertical translations, applying those. Our horizontal, we used f of x minus h, which is our left or right movement. And our vertical is our f of x plus k, which is our up or down. Now using f of x is just a way to signify a certain function. It doesn't necessarily have to be f, it could be h, k, any of those there. Now the other one we talked about was reflections. And if it was across the x-axis, we use negative f of x. And if it's across the y-axis, it's f of negative x. So these are the four we went over yesterday. We'll do one or two more with our reflections, and then we'll look at the last two, horizontal stretch and shrink and vertical stretch and shrink. So the next problem that we had was this one here. F of x equals negative absolute value of x plus 2 minus 1. And we have a reflection over the x-axis. Now it doesn't give us a specific name of the function it wants us to use, but we'll call it g of x. So we're going to say g of x. Now since it's a reflection in the x-axis, our notation is, and we would have the negative out front, yes. Because across the x-axis, it's negative f of x. If it had been across the y-axis, we'd have f of negative x. Now, since we still have the f of x, there's nothing different inside the function. We can just replace it with the function it gave us. So we'd have negative absolute value of x plus 2 minus 1. And the last thing we need to do is distribute the negative. And again, when we multiply a negative or a number by an absolute value, it stays outside, so that negative will multiply by the negative out front. And a negative times a negative is a positive, so we have just the absolute value of x plus 2. The negative in front of it became positive. And our negative times negative 1 would be plus 1. So that there's our new function. Any questions on this reflection in the x-axis? Are we good with this here? We ready for the next one? Our last one of reflections is this here. We want to reflect the function f of x equals 1/2 x plus 1 over the y-axis. Now, it didn't tell us a specific name for the new function, but we can call it g of x. And since it's across the y, we'll have f of negative x. This time we did change the x inside the parentheses for our function, which means every x in f of x has to be replaced with our negative x. Yeah, so we're replacing every x in this here with negative x. So we would still have the 1/2, but instead of having x, we have negative x plus 1. Well, we do need to multiply those two together. So 1/2 times negative x is going to be just negative 1/2 x. And then we have our plus 1. So we just had to multiply those two together, and then we have our answer. Any questions on any of this here? Are you ready for the next part? The last kind of transformations that we're going to have are horizontal stretch and shrink and vertical stretch and shrink. Now let's look at vertical first. Our kind of notation for vertical stretch and shrink is going to be our a times f of x. And whatever the value of the stretch or shrink that we have, we'll replace it with a and then simplify, kind of doing what we did for kind of reflections across the x-axis. Because instead of multiplying the entire function by -1 or our negative, we're going to multiply it by a number. Now the other one we have is our horizontal stretch and shrink. We didn't talk about these when we were identifying parts of the function, but they act a little differently because it is a horizontal stretch and shrink by a factor of 1/a. So whatever value they give us for the stretch or shrink, we're going to have to flip it. So if they tell us it's a stretch of 2, the number we actually plug in is not 2, but 1/2. We have to have its reciprocal. If they tell us it's a shrink of 1/3, we don't plug in 1/3, we plug in 3. And that's really the key with our horizontal stretch or shrink. We have to have this flip. Any questions on this so far? So it's going to probably make a little more sense when we actually do these than it is to try to just look at the definition. Now the first one we have is this one here. Write a function h, so h of x, whose graph is a vertical stretch of the graph of f by a factor of 2. So vertical stretch and shrink. This would be either our a times f of x or f of a times x. Which one of these two would we use? Would a be inside or outside of the parentheses? Because which one is attached to vertical? They didn't put it over here. Vertical is which one? A times f of x. So is a inside or outside the parentheses? Outside. Any questions on this so far? Now the next thing we need to do is find the value of a. In this case, a would be what? How much are we stretching it by? 2. So the value of a is 2. So we'll say 2 times f of x. Now all we need to do is replace the function f of x with what they gave us. Now since it's still just f of x, we're just replacing it with the original function. So we'll have 2 times, so parentheses, absolute value of x minus 3 minus 5. And just like with our negative, when we multiply through with the negative, we'll do the similar thing with this 2. So we're going to multiply 2 in the absolute value. And just like with the negative, the 2 is just going to stay out front. So we have 2 times the absolute value of x minus 3. We don't multiply it with the x and negative 3 inside the absolute value, it just stays out front. But we do need to multiply the 2 and negative 5, giving us negative 10. And that's it. Any questions on how we applied this vertical stretch of 2? We feel comfortable with this so far. We're ready for the next one. Now we do need to change the note sheet a little bit because I did go back to doing these with horizontal. So this time we want to write a function whose graph is a horizontal shrink. So here we're using f of a of x. Now because it is a horizontal stretch or shrink, in this case a horizontal shrink, we can't just plug in 1/3 as a. Because with horizontal stretch and shrink we have to flip it. So 1/3 would become 3. So whatever the factor is with horizontal stretch and shrink, we have to flip it. We have to have its reciprocal for us to actually have the real amount. And this is the only one out of our transformations that we have to do this with. Because if you remember yesterday, our left and right shift, if it was to the left, it was negative. Just plugging it in as a negative, it took care of itself. Because our h minus whatever that value is, it became plus. That is the opposite, so that took care of that. Here, this is the only one we have to actually manually change. So when we plug it in, we'd say g of x is equal to f of 3x. Because we plug in that value for a, giving us 3x. Any questions on this here before we do our next step? Have we got the 3 or f of 3x? Now, do we have f of x anymore? No, we have f of 3x, which means every x in the original function has to be changed to 3x. We only have one x. So we still have the absolute value, but instead of having x first, we now have 3x. Minus 3 minus 5. Now we don't necessarily need to keep the parentheses around the 3x. So we can drop them, giving us this here. The absolute value of 3x minus 3 minus 5. Questions on this problem so far? So if we look at this here, the real trick to this problem is not so much the plugging in or doing any of that. It's just making sure to remember to flip to get our value of a. Any questions on this here? Now what I do want to do is I want to show you this in what a horizontal stretch or shrink in this case looks like. So we have math, absolute value of x minus 3 minus 5. So here's our normal function. Now if we talk about it being a horizontal shrink, it means it's going to increase slower along the x-axis. So if we type it in, math, absolute value, 3x minus 3 minus 5, and hit graph, we see that it does indeed increase slower along the x. And that's it. Any other questions on this here? All right. Let's look at the next one. This one here, again, write a function g whose graph is a horizontal stretch of the graph of f by a factor of 5. Now, just like with the last one, g of x is equal to f ax. Exactly. We'd have to flip it. We would indeed have to flip it. Mm-hmm. 1 over 5x. Now you can write it below it, but I'm going to write it to the side just so we can still refer back to this function up here. And again, just like with the last one, we're going to place every x with 1 over 5x. So we'd still have absolute value, but instead of x, we have 1 over 5x. Yep. Any other questions over this here? I don't know, but it's, yeah. I think I would have sympathy for that cricket if it wasn't for the fact that he's been going at it for over the last 20 minutes. I think so. What do we think of these stretch and shrink so far? It's kind of similar to how we treated the reflections, especially with how we applied it to the function, except instead of a negative, we have a number, yes? And the only one that's tricky is horizontal because we've got to flip that value. Now this one here, h of x, is a be on the outside, really shrink or stretch, it's going to be on the outside. Now luckily when applying the function, applying the stretch or shrink, it doesn't matter if we mix it up, we just have to know that we're doing a times f of x. And our a value in this case is 0.25, 0.25, yep, 0.25. If you want to write it as a fraction, you can, but just make sure you convert it all to fractions, if there are fractions necessary. Now, just like with the previous ones, we need to just replace our f of x with its function. Yep. X minus 1, absolute values plus 2. And now that we have that written, we need to just distribute. So we can do the 0.25 times our absolute value, which would we will have that with the plus 2, or with our absolute values, because we do it first. So we just put the number in front. Now exactly 0.25 times 2 is 5. Yeah. Mm-hmm. Yeah. 0.25 is a quarter. 0.25 is a quarter. If you have 2 quarters. Mm-hmm. We have this here. Now if we wrote it as fractions, this would be 1/4 times x minus 1 plus 1/2 would be the same thing. No, that's an option. Mm-hmm. But I will, it would not be incorrect, but if you do change one of them to a fraction and the rest can be rewritten as fractions, go on and write them all as fractions or all as decimals. Don't be switching between one and the other. I mean, if you like working with fractions better than decimals, you can switch over.
So why don't we just do it? Why don't we do it like the other one, where we erase the 0.25, just put x minus 1 plus 45? Like we got rid of that when we distributed it.
In the last one, because it was a negative already, because we had a negative and a negative, gave us a positive, we don't have to write the plus. Because I think the one you're talking about is one before this here.
Yeah.
Because a negative, this negative times this negative, gave us a positive. So
we got rid of that.
Because positive is understood.
So if it's a negative, we just get rid of that number. If there's a number there.
If there's a number in front of it, so if this 5 had become positive, then we would write plus 5. But the positive value in front of the absolute value is understood unless we have something in front of it. So if I flipped it, I would have to say, if I said negative 5 and had the absolute value second, then we would need the plus sign to show that it is positive. Does that kind of make sense? Yeah, because it was negative 1 times the negative 1 in front.
That's why I read it. That's why I wrote it
that way. Yeah.
That's why I wrote it.
Plus.
As if like you got rid of the 0.25.
Yeah, that makes sense. Yeah. So, and again, a lot of this with Algebra 2, we've got in a habit, especially with mathematics, and y'all can agree or disagree with this, that it has to be difficult. That it's got to be harder than what it seems. But if we take it as kind of we're doing here, this step-by-step approach, it's going to make it reduce some of that for us. So if we look at this one here, we have a vertical stretch of, or not vertical stretch, but vertical shrink of 1/3. So what are we going to use this time? So we'll have g of x is equal to a f of x, a times f of x, where a is our vertical stretch or shrink. Well, our vertical shrink in this case is almost. Outside parentheses is exactly what we think it is. So this would be.
Oh. Wait, why?
I'm sorry, I wasn't.
You're good. Vertical shrink. Vertical. We don't do anything to it. Because again, the biggest thing, even with this, because we said inside the parentheses or absolute values is the opposite of what we think. We don't have to do anything when we move left or right because that takes care of it for us. Because as we saw yesterday, we had x minus -4. Well, the negative made a plus, which is kind of making it go opposite. Because plus we would think right, but it's actually moving left. Horizontal. We have to flip it because even though it looks like a shrink, it's actually a number that looks like it's a stretch is a shrink, and the ones that look like shrink are stretches with horizontal. So vertical, if it's outside the parentheses, if we're plugging it in outside, especially once we get it simplified, so here, it's going to be exactly what it looks like. Because 1/3 between 0 and 1 is a shrink. Yes. So we'll put it out front first, inside parentheses. Now the reason I do this is to remind us that we have to multiply it through. Yes. Because we indeed are going to have 1/3 times the absolute value of x. But we also have to multiply it by the 3. We have to multiply it by both. So if you cut a pizza into thirds, 3 slices, and you have 3 slices, how many do you have? 3 slices, but they make a whole. Yeah. Yeah, 1/3 times 3 is 1. Yeah.
Because you have to multiply both of them.
Okay, I can't do math in my head, but I can write it down.
Yeah, then use a calculator because there's nothing wrong with it.
Well, the pizza.
Yes.
Look at it, it's like.
Yeah, because if we cut a pizza into thirds and you've got 3 of the thirds,
I was
got a hole.
thinking of a regular slice of pizza, like 3 slices.
no, you cut them into thirds.
Yeah.
So if you had a third of a cup of milk and you got 3 of those thirds, you have a whole cup. Questions on this here?
How bad was it yesterday?
Let's look at the last part. Combining transformations. Combining transformations. The biggest thing I will say with combining transformation is take it one at a time and do it in the order in which they're listed. So let G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up of the graph of f of x. So don't try to do this all at once. Do it one step at a time. Now the final function, we'll call it G, but for our first one, we'll say h of x. So this is really just to distinguish between the different functions that we have. So if, let me go back one here. If I was just saying f of x, looking at the screen, would you know which function I'm talking about? So the one that, because this one here is f of x, yes? And if I just said g of x, we're talking about this one here. It gives us a way to name it, because if I didn't have this as g of x, I also had this as f of x, and I told you which one is f of x. Or I could have been referring to the one below, because they are both f of x. Or, as you learned in Algebra 1, f of x is just another way to say y, because if I just said the equation that has y equals, how many of it do I have on the screen right now? 2. So I could be referring to either one. So when we add this function notation, it gives us a way to distinguish between 2 different functions, because I now have a way to distinguish between the 2. And also, if you're using especially like code or values or equations, I can plug in multiple equations and reference them. We won't do coding in here, but that is a use that these can be used for. So it just gives us a way to name it. So we've been using f of x on all these here just because the original function that we were manipulating was f of x. So we could switch it to h of x and it still works the same. Now looking at this here, what is the first translation that we have? A vertical shrink by a factor of 0.25. So that's our a times f of x. In this case here, our factor of a, our value of a is 0.25. Our function f of x is just x. F of x equals x. We could put parentheses around it. So the 3 comes next. Because right now we're just focused on our first translation for information. So it'll make sense here in a second. So the first thing we've done to this function is done a vertical shrink by 0.25. So we applied that to the function. And after applying that, we get 0.25x. So we've done the first part. We've done this, yes? Followed by a translation of 3 units up. Now we're not talking about this function anymore that we're applying the translation up. We're applying it to this one here. So our final g of x is going to equal our h of x plus j. Now I switched it from our original one because the original one talked about f of x plus kf. But when we did that, we were applying all these to the function f of x. What are we applying it to now? H of x. So we see how we changed the notation? Because it's just referring, now we're referring to h of x, not the original function, f of x. So what's the value of k? And it would be plus, because it's going up. Now we can do this all at once, because we can replace h of x. We don't necessarily have to rewrite h of x and then rewrite the whole thing with h of x in it. But our function h of x is represented by our 0.25x. And when we simplify, it'll tell us that our final function is 0.25x plus 3. Yes. So if you look at this here, really, all we did for combining is the first one I did was some of the ones we did with vertical stretch and shrink.
It's a lot easier to put together than one.
So before we even set, we have to do this first.
Yeah. And to try to keep track of the order, there's not a specific one outranks another. Who came in the sentence first? So as you read the sentence, let G be a vertical shrink of 0.25. It showed up first, so it's going first. Then, a translation 3 units up. It comes second.
If we do homework, can we just put it together like the second one got UX?
Yeah.
We can just put it together like that.
Yes, I am not going to dock you or take points away because you don't have the final one as g of x or h of x or whatever it specifies. I'm looking purely at the function itself. Does that make sense?
So we can just put it.
Yeah, you can put y of x, z of x, q of x.
I just have to do
Yeah, I do them differently so that when I don't just have g of x, because it'll help you keep them straight, hopefully. If you do have any questions on the homework, please let me know. Let's look at the next one. Let G be a translation 6 units down, followed by a reflection in the x-axis of the graph of f of x equals the absolute value of x.
So this would be x minus 8.
Yes, so we'd have f of x. H of x would be equal to f of x plus k, because we're talking about up or if it had been left and right, yes, it would be f of x minus h. Now our k value would it be positive or negative? Negative because it's going down. Now at this point here, because in all the previous we'd be putting f of x and that's fine, but what is f of x? There's nothing to say we can't plug both in at the same time.
So when we get to.
So when that be it?
So that'd be it for the first part. Reflection in the what? Because our reflections are going to be across one or two places. X or y. Negative f of x. So our final function g of x is going to equal negative. Normally we would say f of x, but since we're doing a combination of them, we'll just use the notation that we had for the previous one, which is h. Yeah, because now we're talking about this function here, not this one up here anymore. Does that make sense?
So wait. How can we.
So we have negative. So what is h of x? So we put the absolute value of x minus 6. Almost, we do have to distribute that negative.
Oh, yeah, I did 6. So it'll be funny.
So we would indeed have the plus 6, and the absolute value of x would be negative, because the absolute value was positive. So when I multiply it by a negative, it will become negative. So the final function for this here, g of x, is equal to the negative absolute value of x plus 6. And again, on any of these here, take them one step at a time, just like we were doing the individual ones. Take them one step at a time as they appear. Any questions on any of this here? Okay. Do we want to see one more?
Yeah.
So this one here is not listed in the notes. I think I took it off. Let the graph of h be a horizontal stretch by a factor of 8, followed by translation 10 units down of the graph f of x equals x. So, write a rule for h. So this time we can start out at g of x, so it's a f of x. F of ax, yes. F of ax, because we're talking about a stretch by a factor of 8. So that would be first, followed by a translation of 10 units down. Now we need the value of a. So what would a be? Yes. Because what are we talking? Because horizontal, we do have the 8, but it has to be changed to 1 over 8. 1 over 8. Horizontal, stretch and shrink, we've got to flip it. And if it's helpful, especially in your notes, especially on the review sheet or writing this down, writing flip the value, putting something to remind yourself to flip it with horizontal, stretch and shrink, that's going to be helpful. Because for this here, we'd say g of x is equal to f of 1 over 8 x. Well, our function f of x is just equal to x, so we just replace that x with 1 over 8 x. Now the other part of this is translated 10 units down. Yeah, g of x plus k, and I think as y'all are jumping to, because our k would be negative 10, and what's g of x? That's it. Your assignment is this here.